So here's lesson 10, solving absolute value equations. The objective for this lesson is to solve equations in one variable that contain absolute value functions. The absolute value of a number is that number's distance from zero on a number line. That's what absolute value means. That's what, when we start talking about this, that's what we're going to see, that there's almost always two solutions to a lot of these, because it's the distance from zero to the right in the positives or the distance from zero to the left in the negatives. So to solve an absolute value equation, we perform inverse operations to isolate the absolute value function on one side of the equation, and then we must consider two cases. So let's take a look at this, case 1 and case 2. The first case we want to look at is the absolute value. That's what these bars mean, these bars here next to the x. The bars mean absolute value. They actually act like parentheses as well, so if you had a number out in front of them, it would be multiplication or distributive property going on. What we want to see here is case 1, the absolute value of x. That's how you read this piece here, the absolute value of x equals 4. So again, the absolute value simply means how far away from zero on a number line are you. So let's go down to this number line at the bottom of the screen and take a quick look. So 4 units away from zero on the number line. 4 units. 1, 2, 3, 4. So that's 4 units away. The distance is 4. So what do we see? We see that negative 4 is where we land here. So the absolute value of negative 4 is 4. So here we notice x can be negative 4. The absolute value of negative 4 is 4. That's a true statement. Case 2 would be going the other way. So again, starting at 0, how far away, if I go, what's 4 units away from 0? Well, let's go this way. 1, 2, 3, 4 units. Well, that's the number 4. So in other words, the absolute value of 4, the number 4, is 4 units away from 0 on a number line. So we end up with two solutions. We get x to equal negative 4 in this case, and x to equal 4 in this case. So our solutions to this are x equals negative 4 and 4. They are both 4 units away from 0 on a number line. Let's practice solving a couple of these. Just like everything we've done before, the first thing we want to try and do is isolate the variable. In this case, we want to isolate the absolute value. So in this first equation over here, the absolute value of x plus 3 plus 4 equals 9. The first thing we're going to want to do is isolate this x plus 3. Well, I have this plus 4 here, so what do I need to do? I need to subtract 4. Whatever I do to one side, I have to do to the other. That leaves me with the absolute value, again, it's just that bar like that, of x plus 3, and 9 minus 4 is 5. Now at this point, this is where I need to consider two different cases. I need to find out when the absolute value of x plus 3 is 5, and I need to find out when the absolute value of x plus 3 is going to be negative 5. Okay, because again, on our number line, if here's 0, 1, 2, 3, 4, 5, so the absolute value is 5 units away from 0. Well, what else is 5 units away from 0? This negative 5 is. 1, 2, 3, 4, 5. It's 5 units away from 0. So we're going to do case 1 and case 2. Case 1, we're going to find out when x plus 3 equals 5. Case 2 is going to be, when does x plus 3 equal negative 5? So looking at case 1, when does x plus 3 equal 5? Well, let's solve this. I have to subtract 3 from both sides when x equals 2. Let's look at case 2. When does x plus 3 equal negative 5? Well, I'm going to subtract 3. That leaves me with x equals negative 8. So let's check this. If I plug in 2 for x, I have the absolute value of 2 plus 3 equals 5. Does the absolute value of 5 equal 5? It does. Let's check case 2. That would say the absolute value, I'm going to plug negative 8 in now for x. Absolute value of negative 8 plus 3 equals 5. Negative 8 plus 3 is negative 5, so the absolute value of negative 5 is 5. And again, this is saying, is negative 5 units away from 0? And that's true. The absolute value of negative 5 equals 5 is true. Let's look at the second example. 4 times the absolute value of x plus 2 equals 24. Notice I said times. Whenever you have absolute value and you have a number outside of it, the absolute value bars act like they're parentheses, so you can distribute. We've also talked about getting rid of this, so if I want to isolate the absolute value, I would need to get rid of this 4. Well, to undo multiplication, we can use the multiplicative inverse, so 1/4, multiply by 1/4, or we just simply divide by 4. It's the same thing. So I'm going to divide by 4. When I divide by 4, I'm left on the left side with just the absolute value of x plus 2. And 24 divided by 4 is 6. So again, now I'm looking for what is 6 units away from 0 on a number line. So let's look for case 1 and case 2. Case 1 is going to be when x plus 2 equals 6. Let's find out what x is. I subtract 2, and I'm left with x equals 4. Case 2 is going to say when x plus 2 equals negative 6. I'm going to subtract 2 from both sides, so x equals negative 8. So let's check and make sure this is true. If I plugged 4 in for x, over here I have the absolute value of 4 plus 2 equals 6. In other words, does the absolute value of 6 equal 6? That's true. Over on case 2, I would have negative 8. The absolute value of negative 8 plus 2 equals 6. And negative 8 plus 2 is the absolute value of negative 6. And is negative 6 a distance of 6 units away from 0? That's what this says, and that's true. It is. It's 6 units away from 0 to the left. So it's a true statement. So my solutions here are x equals 4 and negative 8. On this left-hand problem, the solutions were x equals 2 and also negative 8 in this question as well. Let's see some special cases now. We've seen this before where when we were dealing with two different variables that you could have no solution or you could have only one solution. Here's going to be the same thing. We're going to have examples where you may only have one solution and you may actually end up having no solutions. So this one on the left, this is going to only have one solution, okay? And you'll see when what's going to happen is going to cause that. The first thing I need to do is to isolate my absolute value. So in order to do that, I have this plus 3. I need to use the additive inverse. So add a negative 3 or subtract 3, leaving me with the absolute value of x minus 2 equals 3 minus 3 is 0. This right here is the telltale sign that you're going to only have one solution. Okay, so I can look at case 1 and case 2 just as I always would. Case 1, case 2. Here's what's going to happen. I'm going to say x minus 2 equals 0 is case 1. And case 2 is going to say x minus 2 equals, I guess, negative 0. But negative 0 is just the same thing as 0. So really I'm just solving the same thing here twice. X minus 2, in order to solve this for x, I need to add 2 to both sides, leaving me with x equals 2. And on the right hand side, I would be adding 2 to both sides, negative 0, whatever that means, plus 2. That's going to leave me with still just x equals 2. So notice I get the same solution in both cases. It's one solution. Let me plug it in just to check. So it's going to say the absolute value of 2 minus 2 plus 3 equals 3. Well, 2 minus 2 is 0. The absolute value of 0 plus 3 equals 3. How far away is 0 from 0? Well, it's 0. So 0 plus 3 equals 3. That's a true statement. Let's see where we have no solution now. Why might this work out that we have no solution? Well, we know one thing. We know distance always has to be positive. Even if I'm going to the left on my number line, even if I'm going in the negative direction, I've still gone 1, 2, 3 units. I didn't go negative 3 units, I went 3 units, even though I happened to go left. So negative signs are just kind of telling me an orientation or a direction on my number line. It's not actually telling me I went negative 3 distance. So absolute value is always going to end up being positive since it's always a distance away from 0. So if we end up getting something where the absolute value equals a negative number, we're going to realize that that can't be a true statement. There's going to be no solution. And that's what's going to happen right here. I have this 5 equals the absolute value of x plus 2 plus 8. Well, I want to isolate the absolute value. In order to do so, I need to subtract 8 from both sides. Additive inverse. That tells me 5 minus 8 is negative 3 equals the absolute value of x plus 2. So what does this read as? This says x plus 2 is negative 3 units away from 0. It's not saying it's going towards the negative 3 number, not going towards the left. It's saying it's a negative distance, and that can't happen. We can't have negative distances. So if we wanted to, we could try to look at case 1 and case 2. And it's going to say negative 3 equals x plus 2. Well, let's see, when that's, if I subtract 2 here, subtract 2 here, negative 5 equals x. When I check this, though, we'll see that negative 3 equals negative 5 plus 2. That says negative 3 equals the absolute value of negative 3. And that's not true. Negative 3 is not negative 3 units away from 0. That's not true. Case 2 would be, I would have to look at 3 equals x plus 2. Absolute value, I'm sorry, yeah, just x plus 2. Erase that. 3 equals x plus 2. Subtracting 2 tells me 1 equals x. Let me plug that in. Does negative 3 equal the absolute value of 1 plus 2? So is negative 3 equal to the absolute value of 3? That's again not true. The number 3 is not negative 3 units away from 0. That's a not true answer. So both of these solutions do not work, leaving you with no solution. All right, so short little lesson today. We'll work a lot more in class on this. To bring in tomorrow, please make a copy of this graphic organizer. It'll only take you a minute. And complete it. Where it says no solution, create your own absolute value equation that's going to end up having no solution. Where it says one solution, create your own one solution type absolute value equation. And infinite solutions. Let's go with, instead of infinite, 2 solutions. Any absolute value equation that has exactly 2 solutions. All right, I will collect this tomorrow in class. Good luck, have fun, and I will see you then.